Let's look at parallel and perpendicular lines. And if you remember, parallel lines are going to go on and on the same distance apart and at the same angle. And since they're at the same angle, we know that their slopes are the same. And we know that they never cross. They never meet. Perpendicular lines, on the other hand, definitely meet. And they meet at a perfect right angle. And the slopes of those lines, if this one is one slope, the second slope is the opposite reciprocal of the first. So they're opposite reciprocals of one another. So for example, I'll show you a couple. If I look at this equation I have, if I think about it in the y equals mx plus b form, my m, or my slope, is 2/3. And my slope of any parallel line is going to be the exact same, or 2/3. Now my y-intercept will be different unless it's the exact same line, but the slopes should be the same. Now if I want the slope of a line perpendicular to this equation, I have to pull out my slope for the original equation, and that's going to be 4/5. The slope, and we'll use this little symbol to mean perpendicular, the slope of the perpendicular line is going to be the opposite, so I have to flip the sign, and reciprocal, so I have to flip the fraction too. So I have to flip, flip. So the opposite reciprocal of the line. I can give you the equation of two lines and ask you, are these lines parallel, perpendicular, or some other combination, like they intersect but not at a right angle? So first thing I'd like to do is pull out my slopes. This first one is already in the mx plus b form, so the slope is 4/5. And then for my second equation, I want to put it into mx plus b form, so I'll subtract 5x from both sides, and I have 4y equals negative 5x minus 20. I forgot to put the minus there. And then I want the y by itself, so divide by 4 on all terms, and I have y equals negative 5/4 x minus 5. So the slope of this line is negative 5/4. If I compare my two slopes, for the first line my slope is 4/5. For the second line it's negative, so I did flip my sign, and I did also flip the fraction, so these two lines are perpendicular. And you give it a try down here. Okay, for number 1, neither one of them is in mx plus b form, so I'd like to move them. Then 3x, so I have 7y equals negative 3x minus 4, and divide by 7, and I have y equals negative 3/7 x minus 4/7. M then is negative 3/7. And then for this equation, subtract 6x from both sides. 14y is negative 6x plus 2. Then I want to divide everything by 14 to get that y by itself. And I have y equals, I want to reduce this, divide each by 2, so negative 3/7 x, and then this comes out to 1/7. So this slope is also negative 3/7, and since I have the exact same slope for both, then my lines are parallel. Let's look at the next problem. And the first thing I see is that it's not in the y equals mx plus b form. So I'd like to put it there, and to do that I get y by itself. So I'll subtract 3x from both sides, and and I have negative 2y equals negative 3x minus 10. And then I still want the y alone, so divided by negative 2 on all terms. And the negative 2's reduce, and I have y equals, this comes to 3 halves x and then plus 5. So if I want to pull out the slope, it's in the y equals mx plus b form. So my slope is just the 3 halves. Alright, this other equation, let's look at it over here. And I want the y by itself again, so subtract x from both sides. And I have 2y equals negative x plus 2. And I still want the y alone, so divide by 2 on all terms. And I have y equals, this is a negative 1/2 x plus 1. And so in slope intercept form, y equals mx plus b. My m is a negative 1/2. Now if I compare my two slopes, I have 3 halves and negative 1/2. They are opposites because this is negative and this one's positive, but 3 halves and 1/2 are not reciprocals. So this is neither parallel nor perpendicular. Okay, now that we know parallel and perpendicular, we can look at finding equations for lines that are parallel or perpendicular to other lines and go through a certain point. So let's take a look at this equation. 2x plus 3y equals 6, and I can subtract that 2x from both sides, and I get 3y equals negative 2x plus 6. Divide everything by 3 because I'd like to be able to graph this, and I have y equals negative 2/3 x plus 2. So my slope is negative 2/3. Remember, we can look at that as rise over run, and I can also look at it as 2 over negative 3, rise over run still, and my y-intercept is 0, 2 from here. And if I graph that, 0, 2 is right here. My rise of negative 2, my run of 3. Go back to my original point, rise of positive 2, run of negative 3. There's my line. Now, if I look at my line, think about how many lines you could make that would be perpendicular to this line. And I can see that, we'll just use my ruler edge. If I put a line right here, it would, if I did it at the right angle, it would be perpendicular. If I put it here, perpendicular. Anywhere I could put a line and it would be perpendicular. So our question is asking us to find a specific line. This point, negative 3, negative 1, should be on that line, and it should come at a perpendicular angle to this line that's already been drawn. So to do that, I need to know what slope should this line have. So my slope should be the opposite reciprocal, and perpendicular should be, if it was negative 2/3, then it should be a positive 3 halves, and my point is negative 3, negative 1. Now I can use the point slope formula to find out what's the equation for this line. So let's write this point slope formula. Y minus y1 equals m times the quantity x minus x sub 1. And this is my x sub 1 and my y sub 1. So I put in that 3 halves for the slope, the negative 3 for the x sub 1, the negative 1 for the y sub 1. So I have y minus a negative 1 equals 3 halves x minus negative 3. And then I end up with y plus 1 equals 3 halves x times the quantity x plus 3.